which are the exam questions on circle theorems. You should have already done video 13 and revised the various circle theorems. Now is for you to try and attempt each past exam question. Remember, pause the video, have a go yourself, and then play the video, watch my answer, mark you've got it right, and make corrections if you need to. Okay, here we go. Let's start with question 1. Pause the video, 10 seconds, I'll start talking. Okay, simple question for 1 mark. This is rule 1 of the circle theorems: angle at centre, double angle at edge. So we remember that more populated inside the centre of the city than the outside. So x must equal 47 times 2, and we're going to say that's 94 degrees. Okay, if they ask for a reason, they have in here angle at centre twice angle at circumference. That would get you the mark. Next question, pause it, have a go, and I'll talk in 10 seconds. Okay, same rule again, angle at centre is twice angle at edge. This time you have to half it because you want the angle at the edge, so x must equal 104 divided by 2. Okay, and the answer is 52 degrees. And again, if they've asked for a reason, angle at centre twice angle at circumference. Okay, next question. Pause the video, have a go. Okay, it tells us that PQ here is a diameter. Because it's a diameter, we've split the circle into a semicircle. We know the rule that angles in a semicircle contain a 90 degrees. So this angle here at R must be 90 degrees. So to get W, you simply add these up and take them away from 180. So W would equal 180, subtract 90, subtract 67, and you'd get 23 degrees, so 23 degrees. Remember again, this is just rule 1, if it's, the angle at the centre here is 180, so the angle at the edge is 90. That's really rule 1, but a special case of it. They ask a reason here, because angles in a semicircle contain a 90. Okay, next question, pause the video, have a go, mark your work. Okay, it asks us to write down the value of y. Now, it might confuse a few people which of 48 and 20, which of 28 and 40 is it. What I would always do is draw out an arc to see which one it is. So you might say, for example, you draw that arc there, and you say, is this the right arc to draw? And you say, what angles are coming out of that? Well, that angle and that angle, see, this one and this one are coming out of that arc. So that's not y at all. That's of no good to me. So I don't care about that one. So I'm going to go, right, I'm going to draw in another arc. And I'm going to instead draw this as my arc here. So this is my arc. Remember, angles from the same arc are equal. So here, I would draw out myself a line. So from that arc, there's an angle coming out from that arc, and here's another angle coming out from the same arc. Okay, so that's saying that this angle and this angle are the same, so y is equal to 28 degrees, and reason, angles coming from the same arc at circumference are equal. Okay, next question, pause the video, have a go, mark your work. Okay, now this is a tricky question. A lot of kids in the exam got this one wrong. They think it's the same as that type of question there, i.e. angles from the same arc are equal, because that angle and that angle come from the same arc, they're equal. But hold on a minute, this is rule 1. Angle at centre is twice angle at circumference from the same arc. So they've been tricky here, they've made the angles look quite similar, but really this is rule 1. Angle at centre, 84, is twice the angle at the edge. You know, usually we see the picture looking something like that and it's more obvious to us that that would be half, but here they've dragged it out to here to just confuse us. So W is half of 84, which is 42 degrees, and the reason angle at centre is double angle at circumference. Tricky one that. Don't lose a mark for something you know but you just rushed and you just thought, oh, this is easy. So just think about what rules applying in each case. Okay, next question. Just before you do this, again, I'd advise you strongly read the words here. Strongly read the words. There is a trick in this question. Do not fall for it. Okay, so pause the video, have a go. Okay, they've got a circle for us here, and they tell us that this angle here is 134. Because this is a straight line, we can easily work out this angle is 180 minus 34, which is 46 degrees. Okay, so this angle here is 46 degrees. Okay, they've asked us to work out the size of the, and this is the key bit, the reflex angle POQ. The reflex angle POQ. So POQ, we think naturally it's that one. Okay, but they want the reflex, they want the one that's bigger than 180. So they want that one there, so we've got to be very careful. Now we know the angle at POQ is double the angle here. We know this is 92. The reason we know that, angle at centre, twice angle at circumference. Easy. So we get that for free, but that's what a lot of people would have put down as the answer. But the answer is actually 360 subtract 92 degrees to get the reflex one. Okay, so be very careful to read the question, and the answer is 268 degrees. And if you want to get your full working here, I would write angle at R is 46, angle and straight line add to 180, angle POQ is 92 because angle at centre is double angle at edge, reflex angle POQ is 360 minus 92. Okay, we've got ourselves a few questions left now. The next few are going to be a bit more, longer to do. So take a look at the next one, pause the video, think about the rule that's applied, have a go. Off you go. Okay, now, it tells us that PQRS is a cyclic quadrilateral. That's a four-sided shape whose corners are on the circumference of a circle. We know a rule for these. We know that opposite angles add to 180. Now I don't have that angle there, so I can't do anything. But I know that one and that one must add to 180. Okay, now this is quite an involved question. I'm just going to start off by doing the obvious. Doing what I know well. So I'm going to take this angle here, the 3x plus 10. I'm going to add it to the other angle, 7x minus 30. Okay, and I'm going to know the answer of adding the two opposite angles here must be 180. Now I strongly encourage you, do not try and add those straight in your head. You'll make a mistake with the negatives. How many x's? 3x, add 7x is 10x. And then we've got plus 10 minus 30, which is minus 20. And that is still equal to 180. Okay, now let's solve for x. Add 20 to both sides. 10x must equal 200. And then divide by 10, x must equal 20. So without really knowing what we're doing in this question, we can find x. Okay, we can find x. And if we can find x, we can actually label in all these angles that had x in them. So this here must be 3 times x, which is 20, plus 10, which is 70. And this must be 4 times x, which is 80, plus 30, which is 110. And just for interest, this one here is 7 times 20, which is 140, minus 30, which is 110 degrees again. Now, we wanted to prove that the PQ, this line here, is parallel to SR, that line there. Now, you know, unhelpfully in the question, they've made them look not parallel. They clearly look not parallel. Well, how can we do that? Now, remember there's a rule about parallel line angles between parallel lines. Okay, if you've got two parallel lines, here and here, then interior angles, or C angles, add to 180. Okay, so if the lines are parallel, the two interiors add to 180. Well look, if that one and that one were parallel, okay, these two angles must add to 180. If they don't, they can't be interior angles and they can't be parallel lines. Now look, this we said was 110 plus the 70, and that adds to 180. Okay? So therefore, angles P and S are interior angles, colloquially known as C angles. Okay, so they are interior or C angles, and therefore lines PQ and SR are parallel. So it's quite an involved question, but I've seen a lot of these ones coming up. So how I do it in future, I would firstly label the things that they want you to show a parallel. Label that, label that. In order to show they're parallel, interior angles must be at work. So either this angle and this angle must add to 180, or this one and this. Now we don't know this, so that's why I'm not interested in this side. We didn't know what this is, what these are. So if I could show that one and that one add to 180, then they are interior or C angles, therefore the lines are parallel. How do we find these angles? Because it's got x's. Well, we use the cyclic quadrilateral rule. Opposites add to 180. Do a bit of algebra, get what x must be, substitute in what these two angles are. You find that they do add to 180, so they are interior angles or C angles, so the lines you're trying to show are parallel are indeed parallel. Now, I've got another question on the next page. It's not even involving circle theorems. I just wanted to throw in at this point because it's using exactly what we just used, apart from it's not a circle theorem. Okay, so you've got to find x in some way like we've just done, and then show that the angles are interior and so the lines are parallel. So have a go at this. See if you can apply the knowledge we've just done to this past paper question. It's not about circles, but it's just good practice for you. Here we go. Okay, well, let's start off by labelling our lines. AB, we're trying to show that one, is parallel to DC, which is that one. So that's what we're trying to show. We're trying to show them two are parallel. Now, in order to do that, if we could show that either that angle and that angle add to 180, then we'd have interiors. Or we could show that one and that one add to 180, and they'd be interior, or C angles, and hence the lines would be parallel. Now, there's no circle involved here. This is not a cyclic quadrilateral. We're not told that. It's just a quadrilateral. We don't know opposites add to 180. We don't know that at all. How could we find x? Well, we know for sure that all the angles of a quadrilateral add to 360. So let's do some algebra. Let's be sensible with this. Okay, so x, okay, plus 4x, plus 2x, okay, plus 3x must add to 360. Angles in a quadrilateral always add up to 360. Okay, how many x's do we have? Well, we have 10 x's, and they're 360. So 1x, you must divide by 10, is 36. Now we can fill in our angles. This here must be 2 lots of 36, which is 72. This here must be 3 lots of 36, which is 108. Okay, then I would simply say 72 plus 108 equals 180. Therefore, I would just call angle A and D are interior angles, and then I would say therefore AB parallel. Therefore AB is parallel to CD as required, or DC as required, and you're done. You could have done it with these angles here. That would have been 36. That would have been 4 times 36, which is 144. They also add to 180. You don't have to show it for both, just show it for that, and that's sufficient. Because they're interior, these lines must be parallel. Because if they weren't, if they didn't add to 180, there's no way those lines could be parallel. Okay, let's go back to circle theorems now. This next question involves circle theorems and simultaneous equations all in one. Okay, you may have seen this question in the simultaneous equations section. You should therefore know how to do it. Pause the video, have a go, then mark your work. Okay, we've got ABCD is a cyclic quadrilateral. Cyclic means that the corners of the quadrilateral, the four-sided shape, lie on the circumference of a circle. There's only one rule we know about cyclic quadrilaterals, and we know opposites add to 180. Okay, let's do this in a very sensible way. Don't start jumping in trying to simplify your algebra or anything like that. Do the easy things first. These two are the easiest to deal with. They must add to 180. Put your x first, then your y. That's the way mathematicians write it. So x plus y must add to 180. An easy mark for almost doing nothing. Then these two must add to 180. Now don't start putting the y minus 45 here first, because keep the x's first, like you've got above. Otherwise you're going to find it confusing. Also, don't try and combine the numbers yet. You will make mistakes. Just get a mark by writing 2x plus 15, okay, that angle, plus y minus 45 must again add to 180. Now, out of our 4 marks, we've probably got a couple already, just from doing the obvious. Now let's just tidy this up now. This isn't a nice simultaneous equation. Let's combine the numbers. 15 plus 15 minus 45 is minus 30. So I could write 2x plus y minus 30 equals 180. Again, not particularly nice here because we've got numbers on this side. We don't have numbers over here. So add 30 to both sides. To remove that, subtract 30. So you get 2x plus y must equal 210. And hey presto, we've got two nice simultaneous equations, equations 1 and 2. Now, if you're not sure how to solve those, you really should by now, because you should have watched my video on solving simultaneous equations. The aim of the game, get the coefficient or the number in front of the x or the y the same. Well look, we've got the same number of y's, 1y and 1y, so we don't have to do anything. All we do is take equation 2 and subtract the whole of equation 1. 210 minus 180 is 30. Y take away y is 0. That's why we want them the same. We want to eliminate one of the variables. And 2x take away x is 1x. So we've got x is 30. Fantastic. How do we find y? Well, we substitute the x is 30 back into any of the equations above. But look, that's the easiest one. If x was 30, what must y be to add to 180? Well, y must be 150 degrees. And we've got 30 and 150. And we've got 4 marks on quite an involved, difficult question, but just by writing things down sensibly and doing the obvious, okay? So don't try and jump steps here. There's a big lesson to be learned. It will make everything go wrong. Okay, 2 more circle theorems questions and then we're done. Okay, they're involving the 2 last rules. Here we go. Pause the video, have a go. Okay, a 5-mark question here. It talks about a cyclic quadrilateral. Here's our cyclic quadrilateral. The edges of the four-sided shape lie on the circumference of a circle. There's a rule we know there, and maybe if you're brainstorming, opposites add to 180. Okay, so we may use that a little bit later. Okay, now let's just try and see what we're trying to do. Show that AB is parallel to CD. Let's draw in the lines we care about. AB is this one here. It's parallel to CD is that one there. Okay, now we are trying to show they're parallel. That's using some of the previous exam questions we've done. If we could show that this angle and this angle added to 180, they'd be interior, or C angles, then the lines would be parallel. Or that one and that one, if they added to 180, then they'd be interior and the lines would be parallel. So that's the same old, you've seen this a few times now, this is coming up a lot. This sort of thing is coming up lots and you should be familiar with it now. Now, whoa, where do we start? There's so much going on here. Do the obvious. Do what is very, very obvious. The first, I think the most obvious thing, this line here is a tangent. Okay, and therefore it's a straight line. Now, what must that angle be there if these are on a straight line? Well, if that's 58 and that's 78, they add to 136. So you subtract that from 180 and get that that whole angle there is 44 degrees. You probably get a mark for doing the very obvious there. The next thing I'd probably go for, the next easiest, is you know that opposite angles in a cyclic quadrilateral add to 180. So this angle here must be equal to 180 subtract the 78, which is opposite it. Okay, so that's another easy source of marks. And that would make that 102. Okay, 102 degrees. Now, unfortunately, there's one of the alternate segment theorem, which is a tricky rule, is at play here. Remember what that says. It says if a tangent meets a chord, the angle it makes is equal to the opposite angle in the shape that's made in the circle. So that's 58. And similarly, this is a tangent meeting a chord, making an angle of 44. That must mean that is also 44 degrees. Now, actually, we're actually done on this question now, because look, these two angles here, the 34 and the 44, add up to a total of 78 degrees. Okay, now look, if that's 78 and that's 102, because 78 plus 102 add to 180, degrees, then you know the angles in B and C are interior or C angles. Therefore, okay, this tells us that lines AB is parallel, okay, to line CD, and you're done. And it's exactly like the other ones, but it just involved another circle theorem, this alternate segment. That angle equals that one equals that one. Okay, so there was quite a lot on play here. There was angles on a straight line going on. Okay, there was alternate segment theorem. There was opposite angles in a cyclic going on. And there was this interior or C angle stuff. So a lot going on, but 5 marks are gettable. 5 marks. That's an A-style question, but I think it's gettable if you know your circle theorems. Okay, last question. This involves one of the last circle theorems. Pause the video, have a go, mark your work. Okay, the diagram shows a circle centre O. AT and BT are tangents. Now we know if a tangent comes from the same point and touches a circle, then the lengths of these two the length of the line to get to touch the circle is the same. So this and this are the same. So obviously that tells me that this triangle here is obviously therefore isosceles. So that angle there must be x as well. Okay. More than that, we know that when a tangent meets a radius, here's a radius, and here's a tangent, they always make 90 degrees. So that whole thing's 90. Now, if this bit's 32 and the whole lot's 90, x must be 90 subtract 32, which is simply 58 degrees. And we've got x nice and easily. Now, if we know x is 58, i.e. that's 58, and that's 58, okay, this is therefore our isosceles triangle. Y is simply 180 minus 58 minus 58, and you get 64 degrees. And you're done. A 3-mark question there, quite straightforward. Just remember the key points. When a tangent touches a radius, 90 degrees is formed. Two tangents coming from the same point are the same distance and usually make an isosceles triangle. Okay, thank you for watching this video on circle theorems. I hope you found it useful in your revision. These are gettable questions in the exam, and you can really push your grade up if you get these type of what are known as tricky questions. Thanks for watching. Tune in for the next video to revise for Unit 3.